So there are no doubts in this week's content, right? So that we could move on to this what we think. Yeah. Okay. So I have prepared a kind of slide. Okay. So I think let's start with the board that we are going to use. So mostly we will be using Wokwi is what we said, right? So this is the Wokwi page and oh, okay, sorry. Yeah, screen is split. Okay. So this is a typical Wokwi page, simulator page that we have. So when you Wokwi.com, this will be the home page that you will see. As you can see, this has options for various development boards that we have and other tools and sample projects that are done with Wokwi is present. Right? So for our course, we will be using this STM type boards and of which the board we will be using is this C03 SDM Nucleo C0 series 31C6. So this is the only board of this thing is available here. Like two boards are from the STM are available in this Wokwi. So we are selecting this board for our course. So okay, that's fine, right? As you can see, this is the model number for this board C031C6. So let's go through the different things. So these are the different IDEs that we have for this development. So for STM boards, there is a separate IDE called STM32 Cube IDE, which you can. So it's like a full ecosystem, which means like kind of tools related together that comes there, right? STM Cube IDE includes all those tools. STM Cube MX is a code generation tool kind of thing. Like there will be a UI, you can set configure the pins in through an UI, and then it will generate template code for you to work on that things. And there is an Arduino ecosystem, you may be aware of this. Arduino IDE is there, and there is also command line utilities for Arduino is there. So that's that. And what we offer simulation. So these two IDEs don't offer any simulation kind of thing. You need a real board to work with it. But what we an online tool it supports simulation of these boards, right? Can write a program and simulate it on a particular board. So there is a VS Code extension. So if you're aware of VS Code, VS Code is a separate kind of general purpose IDE, like supports different languages through extensions. That one. So there is an extension for what we also presented. So if we say Visual Studio Code, this is the and here you have extensions for various types of things. C, C++, Java, Arduino extension is there, and the Wokwi extension is also there. Right. So there are these things. So the online IDE for Wokwi is like very easy to do things like no setup is required, and you can just go on and design a circuit with a board and just write a program and run. There are also these other offline IDEs that are available there, right? So the problem with the Wokwi online thing is you cannot actually deploy connect it to a board and test it, right? If you want to connect it, you need some offline solution. So we kind of like gone through different things that are available, right? So there is this STM cube things, and there is VS Code, there is Wokwi extensions there, and there is also a VS Code extension for Arduino is there. And Arduino also has a mainline utility, right? So these are the different things that are available. So there is also this tool, Arduino Core STM32. So in different embedded boards, in the low level, So there are different levels of programming in any embedded board, right? So, so that's this. So from a lower level, if you see, if you are directly modifying the registers, like very no libraries, no APIs, no code, just take an address, take a memory address, assign it to a variable name, and just modify that register. That is called bare metal programming, right? So for that, you need to know all the registers that are available in a board and what is the purpose of each register to go with it, right? This is what we call a bare metal programming. And there is some drivers that we have, like a low level driver, and this low level layer is kind of a very low level driver, which is like kind of a code, like some libraries that have some low level functions that we can use to configure and modify the. That's what we call a low level API. And there is something called as hardware abstraction layer, which is also a high level API, higher than this lower layer, right? So that offers more control, or like more easier programming kind of code is there. So the thing with hardware abstraction layer is you can use that same code across different STM boards. But if you are writing using a register kind of bare metal programming, the register values may be different from boards to boards, right? So that is not like you cannot take that code and put it in a different, but you have a higher control over how how you can directly for. So some boards may have some additional features that no board has, and that feature you can access using this bare metal program. These all layers are like some general purpose functions will be there, and there is a even more higher level, which is the Arduino API. So Arduino has some functions that like kind of abstract away every detail and gives you simpler functions to quickly prototype with. So there are this. So these are just like libraries. You can think of like libraries where most of the functions are already written for you. So this is a low level library, and this is a higher level library than this low layer. HAL is the hardware abstraction layer. And Arduino API is like a very higher level, so it don't give you options to tweak the small details, but you can like do something in a higher level. If you want more control, you should go to this Hall API. Okay. Is everyone with me? Like any doubts till now? Yeah, yeah. Venkat, Subhash.
Sir, I have actually joined late 10 minutes late.
Okay.
So,
So,
a brief thing what you are saying.
so we've been just talking about different IDEs that are there, like for embedded programming, right? The Arduino IDE, STM, and the Wokwi online thing, and the extension Visual Studio extensions for Arduino and Wokwi are there. And these IDEs, what are the different things that are there? Just going through all that.
Okay, sir.
Okay, this will
Sir,
come later. Yeah,
is this live streamed?
yeah. It's live stream or recorded?
It's recorded. Like we'll upload in the later. Like we'll upload to the YouTube later. Don't worry. And we'll upload in the
Okay, sir.
calendar itself.
Yeah, sure.
To which
Thank
YouTube channel you will upload, sir?
Okay, I'm sharing the link. Okay, 1 minute.
Yes.
Yeah. Okay. Okay. So this is the board that we are going to use. As this is same as the one we have here in Wokwi. Okay. Yeah. So these board. So since we are going to work with this board, we need the reference manuals for these boards, right? So this just there are 3 manuals related to this board. So if you see, this is a uh, instruction, the user manual for this model of the board. And when you see the Hall and LL drivers, the hardware abstraction layer and the low layer drivers is for Nucleo Z0 series. So if you see, all the boards which come in Z0 series will have a uniform Hall and LL drivers, right? And similarly, you can see this, right? This C0X1 32, the C0 processors will have the same kind of registers throughout. So that series is there. So they have common things in common. So these are the reference manuals and their numbers. You can download these if you want. Yeah, I think I'll share this slide also.
Levin,
Yeah.
sorry. Maybe you share it as a PDF.
Okay, okay.
You can just upload in a drive, then share the link. That will be maybe easier. Share it on the forum or discourse.
Okay, okay.
That will be easier, yeah.
Okay, I think then that I'll do after this live session. That will be fine, right? Yeah. Okay, then I'll do that after this live session. I'll post this in this post. Okay. So we have these reference manuals. So I have already downloaded these reference manuals. So this is the first one containing general information about this board and the pin numbers that you have here, right? This has the details about the board, what are the basic things, and this is the hardware layout. What are the things there? The Arduino connector, ST-morph extension header. This is the controller, ST-link, and the reset button, inbuilt LED, UART, the different components of this board, right? In a very higher level view. And then this is the product top side view. You can see this. And okay. The other things, the LED push buttons, this is an inbuilt push button. One is a user button and a reset button. So these components things are there. Yeah. So one more thing is, yeah, this is the thing. So you have different pins, right? So this is the pin number for each of these pins, as you can see. So what does PB means? PB10 means this is the pin number 10 in the GPIO B. So there are many GPIO ports available in this thing, in this board, and GPIO A, B, C are there, and D is also there. So this pin number follows. So this is the Arduino pin number. So this STM board supports like kind of interoperability with this Arduino board numbers. So this Arduino pins that you have here is compatible with the Arduino board also, right? You can also write this. So this Arduino connector. These Arduino connectors are compatible with the Arduino boards. You can connect this with the Arduino IDE and work with that. So these are the Arduino board numbers. If you see the pin number 1 and 2, these are the Arduino board numbers, and the corresponding pin number in STM32 is like there are GPIO ports, different GPIO ports are there, A, B, C, and D. and the pin number will be there. If you are using the HAL libraries, you should be knowing this number and the GPIO port for the particular pin. If you are using Arduino, you can directly use this pin number D, and these are the analog pins, these things. So this is that reference manual for the pin numbers. And what is visually given here is also given here in a tabular form. Right. Arduino D9 is same as C, the GPIO C port, pin number 7, that you can see over here. So this is, can go along and read this, and here you can see what are the features of each pins that you have here about the board. So this is the quick overview for this user manual board, right? And when you are programming in HAL or a low-level driver, you may need this manual. So here you can see this is the things that you need for the GPIO programming, the generic driver for GPIO. So this has, so there are multiple ports. You have to enable the GPIO clock, the code. This is how you initialize the GPIO port. So there are many things associated with this, or very small details. Here you can set, like, configure the pin state, like input, output, high, low. These functions you can see, right? This is a write pin. It's one of the functions that used to write a value to a GPIO port. And there is a read pin functions. These are some defined functions that we can use to interact with the GPIO. So there are other things that we have here. The UART is there, timer is there. So these are the drivers, HAL drivers we use to interact with those things. So if you are using HAL based programming, you need this reference manual to look through different things, right? And in the second part, you also find the LL drivers here, the low level GPIO drivers, the structures that you can find here. So using this GPIO init type, you can set the pin mode, speed of the pin, output type, full, alternate, this configuration. So this provides some detailed configurations, right? These are the API description for these things. So if you are using this programming, you will need this manual. And the other manual is even lower level manual. Here you will actually got to know which are the registers responsible for the things. Right here, this is the bit level description for each of the register, right? The functions that you can see here. What does these values means? What does setting a bit means? Setting the particular bit, what it will set. Those kind of things that you can read here. All the details will be available in this manual, the register level detail. The main features, yeah. So these are the registers, name of those register, bit set, reset register, the input data register, and the other register, output data register, ODR, and these kind of registers you got to know. And by modifying these registers, you can interact with the code, the STM code, right? And if you have used Arduino before, you may know a simple syntax for this Arduino codes. Like here there is a setup and a loop function. These are like the main for this Arduino programming. So this is the setup function is run only once, and the loop function will run multiple times, like repeatedly. It will go on an infinite loop. So what this program does, so this is the Arduino API. So as you can see, these are like very easy to write function. You can directly mention this D13 port, and the pin number 13. You can set the pin mode to output, and I'm setting it to low, which means like off. And then I writing it to high, waiting for 50 milliseconds, 0.5 seconds, and uh, making it low and then waiting for on. So this will make the LED blink, right? This will repeat infinitely. This is the basic program to blink an LED. Okay. These structures that you have here is a very higher level API. That's the Arduino core API. You can see it's blinking there, right? So in this area, you can actually connect circuits. Like you can add a new part, choose the components from here, push button, and you can connect these in any way you want, like that. Now we want, oops, right? So you can design your circuit with these pins and write the code here. So this Wokwi supports all the APIs like Arduino API, the all API, the low level code, any code, all the things are supported by this Wokwi. So you can just without worrying about anything, you can just write the code and run it here. Okay. So till now, any doubts? Okay. Yeah. Any doubts?
Shall we have any tutorial sessions too, sir?
Tutorial sessions?
In the sense, you'll be given some question, and while we are doing, if we get any doubt in the same. I mean, for Linux, we had lab sessions in the same way.
Yeah, some of the sessions will be like that. We will give you a problem. Some of the live sessions, it will be done in the live sessions.
Okay, sir.
So those sessions will be only after like week 3 or 4. This is just to get familiarized yourself with these tools. So for now, you can just try out simple programming examples like blinking the LED, those kind of things. There are a lot of tutorials. You can also use this Arduino code that exists there because this STM is also compatible with the Arduino, right? These Arduino connectors. So you can just try with some boards like connecting the circuit components using Arduino code. The logic behind it, right? You can work with that. The low level, register level other codes that will ensure to go there. So for now, there are a lot of internet tutorials are available for this Arduino based programming that you can try up with the different components, try connecting this to different pins, try out different tutorials like that, right? Just to get you comfortable with these circuits and things, plus in the programming part.
Yes, sir.
The very detailed programming things that will come after week 3 or 4, and then we'll discuss. We'll give you exercises that you can do the live sessions. But it won't be a compulsory thing actually, right? This sessions that we have, like the programming sessions that we have, it won't be a compulsory, but it's good to know that thing.
Yes, sir.
Okay. So these are the basic things about how to set up a project in Wokwi. You have to go to the page, select this, select your board, then you can write this code and play button to simulate it, right? We this. Yeah. So there is this save button. You can download the things. There is the source code editor, and these are the files. You can create new files by clicking over this drop down. You can create new files, format the code, rename files, upload files from your local thing. In this button, if you click here, there will be options for downloading the whole project as a zip, sharing through a link. Those things are available here. And this is the library manager. If you are using any third-party libraries, so most of this Arduino code use higher level libraries to speed up the things, but it's not like very optimal code for just a proof of concept or prototyping things that you can do. If you want to do very optimized code, you have to write very bare metal code directly accessing the things and so on. This is the drop down where you see this is a design area. And this is the start simulation button. You can add components over there. After this is the blink LED code, and here's the simulation that you have. You can pause the simulation also and stop the simulation and do things like that. Right. So these are the setups for things to set up a local uh, setup for this thing, so that the code lives in your systems with this VS Code extension kind of thing. So for that, you need to install these two command line utilities. One is the Arduino CLI. It's available in the website, and the Wokwi CLI if you want to run simulated testers. Other than that, Wokwi CLI is not needed. For visual, so this is needed for compiling the files, like the program. You need to compile it to a certain format so that the work we can simulate it, right? That you need this Arduino CLI. And there are these extensions for VS Code that helps you. This for helps you edit in the edit and debug and compile things in the VS Code. This is for the simulation purpose. And yeah, that's pretty much it. So here there are some configuration files that you need to configure so that your things go well. So I have a example repository here. Yeah. So here all these uh, things are there, like the compilation, the configuration files. This Wokwi 2ML is for the configuration for uh, local simulation for Wokwi. Those kind of things are there. So there will be a, I think the name maybe in the next week I'll maybe show how to install set up this offline. I haven't tried it with Windows. If you have, you can like follow this instruction if possible. Try that in Windows. Maybe we'll also discuss that in the next week's live session. So yeah, maybe I'll show how it looks in an offline manner. Yeah. So this is VS Code. I have opened that repository, which is in my local system. Right. I have put some instruction on the repository if you want try that. Okay, so this is our file. So here I have like a different file rather than this thing. I have a very different thing. Let me put it here also. So this diagram.json file that you find in this every project is the description for the circuit diagram. So this circuit diagram is kind of represented in that format. So if you want to move a circuit diagram from one project to another, you can do by just copy pasting this circuit diagram.json. So see, you can see that I copied that circuit to here. So now I have a different code. So what does this code do? This code is kind of mix of different levels of API. So for the clock, if you see, I'm using this Hall API to compute this delay, the wait function for waiting for 1000 milliseconds. I'm using the Hall API to do that, so that I am initializing the Hall here and do this line serial.begin. This you will see in the Arduino API, right? This is a part of Arduino API, just serial.begin and serial.println, so that the messages come in your serial output, which is through what that you can see. And you can also see I have directly accessed the registers here, the GPIO A. I'm setting the mode for the by settings through some bit manipulation, the speed through bit manipulation, and I'm writing to the pin using bit manipulation. And I'm toggling the pins 5 and 6 using bit manipulation. So here the pin 5 and 6, you see it's in 13, right? Why it's 5 and 6 here? Because of the pin number. So if you see in the here the board information. Yeah. So what is this board? 13. The D13 is actually EA5, which means in GPIOA it's the fifth pin, and 12 is P6. That's why these are pin 5 and 6, even though it is 13. And this 12 is by default also connected with this inbuilt LED4. So that's why that 12. And using this output data register, I am setting the pin 5 to 5. And then here I am toggling the both the pins using some bit manipulation. XOR operator is used to toggle the things. And when we run this online, it will take like some time to compile this thing.
Hello, sir.
Yeah.
Sir, I think your screen is little bit laggy.
Your screen was struck, sir. We are able to still see the Arduino API.
Oh. Okay.
Yeah.
Let's see. Is this visible?
Yes, sir. So you are showing two tabs right now, right?
Yeah, this is the simulation running in Wokwi.
Yes, sir. Yeah. Okay, sir. Yeah.
Yeah. So have you able to see this thing?
Yes, sir. Yes.
Okay. So this is
Yes, sir.
like this code is a mix of different things. The STM hall is there. Using hall, I am controlling the delay. Using Arduino API, I am using the serial thing. And using bit manipulation, I am accessing the GPIO. Right. So these three different things that I am using. And now you can see this pins 13 and 12, D12 and D13 of Arduino. While using this register level thing, I have to modify the GPIOA and the pin number, right? So as per this pin number configuration, 13 is PA5 and 12 is PA6. That's why we are using that. The simple Arduino API, the code will be like this, just setting the pin mode and write the values in the pin number. It's a mix of, just to give you a flavor of different levels of API that we can use and different levels of control that we can get. Using Arduino API, you cannot set this speed of the port, right? And there are some things like that that you cannot set with the Arduino because it's more generic and it's designed to be supported by many boards. But some boards will have also different features specific to that, right? That we can only access if we are using these kind of lower level drivers or the bare metal programming specific to that. Okay, so in the VS Code, in an offline installation, it would be looking like this. I can open my terminal. If you are familiar with Linux, I have installed this Arduino client here, and I also have a make file here. So this is a command to compile this, and we have some configuration files, right? One of the configuration files is sketch.yml. So this configuration file is required because Arduino is designed to compile the thing to that board, right? So which board we want to compile the code to. So we have to specify this STM model number, these things. So that this configuration file is required. This just specifies that you have to compile to this Nucleo C0 series board. And this is the model. And these are the URLs for the library files, the board manager files, which are required for the Arduino client to compile it to the format. And this make file has this compilation command, which is basically Arduino client compile this LED blink to this build directory. So my compiled files, this bin, elf, hex, map, all these are my compiled builded files. Just like the when you compile a source file, you get a output file, right? The binary file. These are those files. And in the Wokwi 2ML, we configure that, like where are the files, so that it can run the simulation based on that. So these are the two important things that you need to set up. And this bake file has this Wokwi CLI is just to like testing the behavior of this thing. Actually, this is not like uh, necessary for you now. You can just try how it's working, right? You can do this start simulator. So initially, when you are setting up, it will ask for your license key that you can get from the Wokwi website. So now you can see this is running the same code that I have here is running locally, right? So it's running locally, but the simulation requires an online internet connection because it has to, your code lies in your local system, but the simulation occurs with the online tool. But in the Wokwi here, the code also lies in the Wokwi website. It's not lying there. But you can also save this like
So there's no need to technically download VS Code, right,
no, no,
for this course.
no, no. You, if you prefer you need to do something offline, you need that. When you are working with the online simulator, like if you need to work with the offline board, you can set up it in a local thing. If you're working with the offline board, and if you want to have your code here in your system. So this Wokwi, there are some premium plans required if you want to make the project private. Otherwise, it would be public. Everything will be public. If you want to do this, it will be there needs to be some subscription on things like that. So you can save the project and you can share. So you need not download that, but if you prefer that to be do something offline, you can try this out. Otherwise, the setup is not required. You can just go with the online simulator. The thing with online simulator is it will take some time to compile when you do this, right? So if you change the code and like compile things, it will take some time to do that. So that is the thing. Online compilation will run on their server, so it will take some time. Sometimes to 15 to 30 minutes it may take. So if you are constantly changing a code, it might be a thing. But here you can compile in your local system, right? So that, so if I want to change this, I can change 5. So this thing is the simulation will be updated as soon as I am running this, right? So making this. So that, yeah, you can see this. It's compiled and built it there. So it will be slow. The high will be more time and it will be less. Low will be lesser time. Okay. Yeah. So you can go ahead and like work with some sample projects from the internet, like the LED Bling using Arduino API for now. That would get you familiar with this. Okay. Any doubts? Okay. Then I think Vidhu can take over.
Yeah. So if you have any doubt, you can ask. Otherwise, we'll close the session.
So this session is being recorded, right?
Yeah, the session is recorded and we'll upload to the
Yeah.
YouTube.
So I didn't receive a email for this session, sir.
It's
So
on
it's
the
just
calendar. It's on the calendar.
directly on the calendar, right?
Yeah,
Okay.
yeah, it's on the calendar.
Thank you, sir.
Yeah, yeah.
And sir, I had doubt regarding the course structure as such. Is there a, I mean, will there be a doubt clearing session on that? Because I just wanted to ask, will there be a quiz too for this thing, or will there be labs? And if, I mean, of course there'll be labs, but what would be the format for that?
So there will be two quizzes, quiz one and quiz two, and there will be one end term. And for the lab will be like provided the practice graded programming assignment. So we'll give the graded programming assignment. So you have to submit the graded programming assignment, and how the tabulation part and all the things will tell later.
So sir, hopefully it will not clash with Linux OPPs
Yeah,
because I have
yeah,
Linux as well this term.
yeah. It will not clash with other things. Don't worry.
All right, sir. And
Yeah,
so for the labs part,
yeah.
will there be just graded and practice questions, or will there be like online sessions for the labs as well?
Yeah. There will be like live session will be there. So will be what we'll do like we'll solve some like that practice programming assignment question or some new question. Then you can able to like learn all the things.
And lastly, although I know, but just to confirm, no offline labs, right?
And yeah, there will be no offline lab.
All right, all right.
Yeah, yeah. Okay. So yeah,
So one question.
Sir,
yes.
sir, can you again explain about IDE? I have watched the lectures, but I still wanted to know more about it.
That
What is
ID
IDE exactly?
integrated development tool, right?
So an IDE is just like a text editor combined with the debugging tools, the all those things. So an IDE refers to something that will help some tool that will help you write programs, debug it, test it. All the tools will be combined. That's what we call an IDE. And there are different IDEs to work with different things. Some people prefer, so if you consider C programming, there is Turbo C++, there is Eclipse IDE. Some people use VS Code and those things, right? So there is this for C, if you have, there is this compiler uh, tool, GCC is there, right? And there are these build tools are there. So some compiler IDEs provide all these things in a package kind of thing. So that's what we call an IE, integrated development environment. Okay.
Okay, so it is compiler and debugger type applications.
Compiler, debugger, editor, everything combined together. All the tools that you need to do the development on language, a programming language.
Okay, sir, and one more thing. Actually, I haven't been added in the embedded C group on Discourse.
Yeah, we'll add. Don't worry, like within this week we'll add on the discourse. Maybe you can tell your type your Gmail email ID. That will be good.
Yes, sir, I'm done.
Yeah. What is your discourse ID? Type your discourse ID also. Discourse ID.
Sir, on Discourse, it's mail ID only. I think there is
Okay.
not a separate ID.
Okay. Okay. Let me try. Okay. Within this week, like it will be added in the discourse. Okay. Any other doubt?
So the manuals will be shared. The discourse or
It will be share in the discourse and the yeah, it will be share. Like we'll drive in, we'll upload in the drive and we'll share.
okay, sir.
Yeah, yeah. Okay, so if you don't have any doubt, then we'll wind up the session.
Sir,
Yes.
since we are having time, can you make us to do some tutorial or something like
Tutorial mean?
using the Wokwi, how to access the manual pages and how to look up some example, at least setting up and blinking LED.
Okay, okay. Levin, can you?
Okay,
So
so
someone of the students will share the screen and you please guide us. So we will get a clear idea.
okay, that's good actually. So if anyone is interested to volunteer, yeah, Venkat, are you interested to volunteer for that?
Yeah, sir. In a minute.
Okay. When you're ready, you can share the screen. Go to the Wokwi homepage.
Yes, sir.
Okay.
So you will be updating the calendar with the YouTube links, sir?
Yes.
Thank you.
Hello.
Yeah. Yeah, Venkat, are you ready? Anyone else more want to volunteer for this?
Is my screen visible, sir?
Yeah. Yeah. Just go to the STM32. Yeah. It's better you have a Wokwi sign into the Wokwi so that you can do later. But like for saving the projects and sharing it, you might require that. Okay, go to start from scratch and
Okay, start from
yeah, the Z0316C6. Seems you are having a very low bandwidth. Things are taking time to load.
sir. Seems like some implementation.
Others also to try this parallelly. How many of you are trying to do this? Okay, can just give a thumbs up or raise hand. Okay. Yeah.
Sir, I guess now the screen is visible.
Yeah, it's so here you have the just first basic code that you have, just the serial printing hello world kind of thing. Okay, so you can start by like so our first Blink code is there, right? So what you can do first, you can like uh, add the LED component and connect it to the pin, the positive pin to the S30, 13 you can, or 12, 12 is fine, anything. Yeah, 13 or 12. Yeah. Now you can just delete the setup and loop, the inner part of the setup and loop. We'll write our own thing. So in the first setup, we have to set the, so just start with the setup.
Unable to type in something.
Oh, you're not able to type in.
Yeah.
We try refreshing the page.
Yeah. Even same, I'm unable to type in.
So which browser are you using?
Edge, Microsoft Edge.
Okay.
Shall I use Chrome?
Yeah, maybe you could try that. It will work without signing also. Not sure. Let me check whether it's working without signing in. Yeah, it's working without signing in. Maybe problem with the browser or the bandwidth. Maybe the problem.
No, bandwidth.
You try. Maybe you try the different browser. Anyone able to get this? Anyone able to type the code? Without signing also it's working. Maybe in Chrome also it's not working. Huh?
No, sir.
Okay. Anyone else? It's working. Now it's
working. Yeah, sir.
yeah. Maybe it's the bandwidth problem. And now there are these two Arduino functions like pin mode. We have to set the pin mode to output pin mode for the pin 13. This is just calling pin mode with the 13 and come out output. Yeah, you have to close the bracket is closed correctly. No, you have to close the bracket for setup.
Okay, yeah.
And in the loop section, you can put 2 delays, and before each delay, you can add the set pin mode. Oh no, not pin mode. The digital write function, which will have to specify the pin number and the data like digital write. I think it will be the capital W and high all caps. Use the suggestions that it shows easier. And after the delay, you can set it to low. Increase the delay so that it be visible, because 10 milliseconds won't be visible properly. And set it to 500 milliseconds or greater. Yeah. Now you can just run it. The pin mode, the M is capital M.
Okay. it's working.
Yeah.
So it's these pins are equivalent to the normal Arduino pins.
Yeah, so you saw the Arduino compatible connectors. The Arduino connectors is also this SDM also has this Arduino compatible pins. And also other pins that you have. Okay. Okay. Anyone other than Venkat able to do this? Any others? Are you able to do this? Are you trying? How many of you are trying? Okay, one of you could also share the screen maybe. Venkat, you can maybe stop presenting. Anyone else volunteer to share your screen? Yeah, Maithili?
Yes, sir.
Yeah.
Sir.
Yeah. It's visible. Your screen is visible. Okay. The LED is not blinking, right?
Yeah.
You are connected in the wrong pin, Maithili. So you have to connect in the Arduino that connectors. You connected in a different Nucleo board that Morpho connectors.
Okay.
It's inside the. You can just click on the wire and click delete, so that wires will be deleted. So click somewhere on the wire and click delete.
I have to stop.
Stop it. Yeah. Yeah. Now when it's click it. Yeah. So that also no, not that. Actually, it's inside. You see the uh, D13 pin. D13 pin. It's inside.
Yeah.
Yeah, that pin you have to take. The next one. Yeah, just connect it there. Yeah. The next wire you can also delete that and take from the ground. Yeah. Yeah. Now you try run.
Yes, sir.
Yeah,
sir.
it's working, right?
Yes, sir.
Yeah.
Sir, how to delete the wire?
Click it and press delete. Okay, anyone else? If you are doing, you can share the screen. Yeah, Maithili, you can
Yes.
stop.
Thank you, sir.
So you can just explore the different components that are present in Wokwi, maybe by doing some online tutorials with Arduino code. There are many tutorials available on the online. You can try that. Yeah, Dhruv.
Sir, can I share my screen? I am
Yeah,
not
yeah,
able to delete the one.
yeah. Just click on the wire. Yeah. Your screen is visible. Click on the wire, not the point. somewhere between the that. Yeah, click there.
Sir, I'm clicking.
So you have to stop the simulation first. Yeah. Stop it. Stop it. You have to stop it. Stop button. Yeah. Now you can. Yeah. Now press delete. Oh, yeah. You can also press delete in your keyboard. Okay. Yeah, connect. No, connect it to ground. Connect it to ground, not there. Yeah. Yeah.
Yes, now it's working.
Yeah.
Thank you, sir.
Everyone, others are able to do this?
Okay, so thank you everyone for joining the session. We'll meet next week. Okay.
Thank you.
Yeah. Bye bye everyone. Good night.
Thank you.